even though there were a lot of critics against Piaget's theories, we still use his theory today, and even today, in the teaching of mathematics in the foundation phase. And one of the most important contributions of Piaget that helps us understand how the teaching and learning process in the classroom should develop is his description of the three kinds of knowledge that learners must acquire for them to be able to deepen the schemas of a concept. But before we look at the three kinds of knowledges, there are quite a few important factors that we must remember, and we will discuss it right now. First one, Piaget identified the three kinds of knowledges, namely physical knowledge, social knowledge, and conceptual knowledge, that's also referred to as logical mathematical knowledge. All three these kinds of knowledges are essential for effective learning of mathematics. These knowledge branches do not necessarily follow a sequential path, but it's considered to be a more of an interchangeable, integrated process in equating the knowledge, meaning it's working in partnership with each other to help learners form internal mathematical ideas and leading them to a conceptual understanding of the mathematical process. For instance, while they're busy with the conceptual part, the social influence and the social contribution will have an influence on the conceptual outcome, whereas the physical manipulation of objects will also contribute to the outcome. But let's start at the beginning. The first kind of knowledge is the physical knowledge. This knowledge consists of a combination of various kinds of information that learners discover and explore through their senses and the manipulation of objects. Remember that we have 5 main senses, very prominent senses. It is to hear, to see, to smell, to touch, and to feel. To be able to hear, to see, to smell, to touch, and to feel. This means that through play and activities that harbor the discovery of ideas, learners can gain knowledge by engaging their senses to manipulate physical objects. Teachers can therefore provide learners with various concrete experiences to develop their physical knowledge in mathematical concepts such as numbers, patterns, space and shape, measurement of quantities, as well as collecting and sorting physical objects to derive knowledge from data. The classroom environment should therefore also lean towards discovery and always encourage active participation. The second kind of knowledge is social knowledge. It refers to the world of personal experiences and is learned from others. Learners gain social knowledge when they observe what others, it could be a teacher or other learning, are doing, or when it is explained to them how society uses this kind of knowledge. For example, children do not initially know how to write numbers. Teachers have to show them how society writes symbols and numbers and how they are used in everyday life. As such, children do not necessarily have the understanding and vocabulary to explain how they know the things they know. It is usually more suitable for them to show what they know and how they know it by using physical objects to convey their thoughts. To build social knowledge in learners, it should be taught. For example, teaching them the names of shapes and the way shapes are used. As stated by Vygotsky, peer interaction forms a vital part of learners' development, and ample opportunities should be made available in class for them to discuss mathematical ideas with their peers as well. By sharing their mathematical ideas in group discussions in class, learners may quickly learn from others and become critical thinkers and proficient in mathematics. As they reason with their peers and teachers about new discoveries, they form deeper mathematical concepts. It is also important to note, however, that not all learners are on the same level of mathematical thinking. Learners come from different backgrounds and are exposed to mathematics in different ways. The methods of teaching and instruction in the classroom should therefore be based on learners' various levels of mathematical development. Without the aid of concrete objects, symbols, visual aids, as well as ample opportunity for discovery, learners will reach a conceptual understanding at their own pace and in their own time. The third kind of knowledge that learners need to acquire in mathematics is conceptual knowledge. According to Piaget, this kind of knowledge is internally constructed by the learner him or herself. We know that once learners have acquired this knowledge, they can reflect on what they know, verbalize their mathematical thinking, and are able to tell others how they know what they know. Therefore, physical knowledge needs to be closely coupled with social knowledge for learners to arrive at conceptual knowledge. For example, for learners to understand the difference between 6 and 7, they need to understand their physical numeric quantities. For example, 7 blocks are one more than 6 blocks. And they need to know how society writes the numbers and the number names and symbols for each. When they possess this kind of knowledge, we can say that they exhibit conceptual knowledge. What is more, conceptual knowledge is not static, but rather adapts and grows as learners gain more experience of concepts. This knowledge is stored but can be retrieved when needed. For example, prior knowledge to explore new concepts and ideas. At this level, the most important task of the teacher is to provide learning opportunities that will enable learners to construct their own knowledge. Teachers need to encourage learners to reflect on what they are doing, to verbalize their thoughts, and to interpret and understand the ideas of others.